In this video, we are going to discuss how to set up an integral over this triangular region and also how we evaluate it once we set it up. So this is not going to be a lot of fun. I'm just admitting that right away. So just hang on for the ride. So first of all, the easy part. The easy part, that would be the x limits. So this is the extreme values of x. So what is this region? If I'm looking at this region right here, what is the extreme left endpoint and extreme right endpoint in terms of x values? So this looks like that would be -5 up to 2. So that's the easy part. So that's -5 to 2. Okay, so we're gonna put that right there. That's easy. The outside limits will not have variables in them. Now, when you are trying to decide what about the inside, are they going to have variables? And if yes, which one? I want you to remember that unless it's a rectangle and it doesn't look like a rectangle, the inside limits will have variables in them. Now, if you want to know which one, the one that's outside. So if the outside variable is the x, as in this case, the limits inside should have the x in them. Okay. Now, how do we come up with these limits? Now, think of yourself as being inside this triangle, right? This is you. Imagine this is some kind of weird house, and this is your house. What is your floor? So the floor is your blue line, right? And what is the equation of that blue line? So we need to figure that out. Well, equation of a blue line, so we want to write it as y equals, is look at the slope, which is rise over run. And so if I look at these 2 points, like this is the point and this is another point that the blue line goes to, the rise is going to be 1, 2, 3, 4, 5, 6, 7, 8, right? And then the run is going to be, I guess, 7, because that's the distance between -5 and 2. So this would be -8 over 7x and then plus some b, which I really do not know. Okay, so that would be one thing you can do. I'm not really sure where that y-intercept is. So I think what we need to do, once we get that slope, we're going to have to solve this for b. And for that, we just need only 1 point. We don't need both of them. So for example, the coordinates of this point are 2, -4. So if I were to substitute the -4 for y, and if I can substitute x equals 2, I can hopefully get that b. And I probably will need a calculator for that because it doesn't look like that's a lot of fun. So this will just be what, -4, and then I add 16 over 7. God, that's not fun at all. So let me just try to figure out what that would be. Okay, it says -12 over 7. Okay, so that is your bottom limit. So this is -8/7. There is no way I could have predicted that by just looking at this thing. I mean, it does look like it's oh, it's negative. It's negative. Yeah, it's somewhere negative between -1 and -2, but that's -12 over 7. I wouldn't have been able to predict that. Okay, now what about your ceiling? That's the red line, right? Okay, so what about that red line? So first let's figure out the slope. It does look like it's a negative slope, right? So if you go from this point to this point right here, what's the slope? Rise over run. So if I go from this point, I think I would have to go down 2 and again 7, unfortunately. So this looks like that's -2 over 7x. And again, plus some number b that I don't know. However, I know that the red line goes through 2, 2. Right? And so I can substitute that and figure out what would be my b. So my b is going to be 2 plus 4/7. What would that be? Okay, so let's just simplify. That's 18 over 7. Okay, again, what is 18 over 7 approximately again? That's 2.5 something. So it does make sense because that's your y-intercept right here, but I'm predicting that it's going to be 18 over 7. That's not, that I cannot do that even though I'm a math teacher. Okay, so here we have -2/7 x plus 18 over 7. And then we were actually supposed to, if you want to know what the question was, let me just get to it. The question was that we were supposed to integrate x. So because that's what the function was. So we're going to integrate x, dy, dx. All right, so let me show you, let's just say that that's correct, and let me show you how to integrate that. So integration of x with respect to y will give you x multiplied by y, right? Because think of x as a number. And now we're substituting y equals negative 8/7 x minus 12 over 7. That's the lower limit. The upper limit is negative 2/7 x plus 18 over 7. Okay. Ooh, fun. Okay, so this is just gonna be, since I already integrated with respect to y, this is dx. Okay, so now I'm substituting this for y. So this is gonna become x times negative 2/7 x plus 18 over 7, right? And then I'm gonna subtract, substituting the same thing. So then this is just going to be x, and then this is negative 8/7 x minus 12 over 7. And then this is dx. Okay, so we're going to have to simplify this, I think, quite a bit and combine like terms. All right, so first of all, distributing the x here, this is negative 2/7 x squared plus 18 over 7x. And then the other one will become actually positive, right? 8 over 7x, and then plus, no, x squared plus 12 over 7x. Okay, so we just have to collect like terms, which is not that hard. Okay, so the negative 2/7 plus 8/7, that is 6 over 7x squared. And then plus, here we have 18 and 12, that's 30 over 7x. Okay, so now we just have to integrate, we'll keep the 6/7, so that becomes x cubed over 3 plus 30 over 7, and this is x squared over 2. Okay, now the rest we can do on a calculator. So let me show you how I would do that. So once I integrated the thing, I am going to define a function on my calculator, call it f of x, and I will just type that whole thing. So x cubed over 3 plus 37 times x squared over 2. Okay, so I want to find f of 2, and I want to subtract f of negative 5. Okay, so it tells me that that is just negative 7. And hopefully that is going to be my answer.